Hello! In this lesson we're going to be talking about transformations of a quadratic. So just a quick glance, there are three major ones that we're going to be focusing on today. The first one is the translation, and that means we're sliding it. We're either going to slide it up, down, left, or right. Flip, that means we're going to reflect it over either the x-axis or the y-axis. And dilation means that we're either going to stretch this or compress it. And depending on what we are multiplying, it's either going to be a horizontal stretch or compression versus vertical stretch or compression. Okay, let's talk about our basic translation, your slide. If you are adding a number to your y values, so f of x is our function, it's the same as your y, so it's basically saying you're going to take all your y or your range values and add a number to them. So if you take your y values and add a number to them, for example, my parent function is x squared. If I add 4, what that's going to do to all of my y values is bump them all up 4, and this image goes right up there. If I take my y values, and remember f of x is basically the same thing as your y values, and you subtract k, that means this is actually going to go down. So this one goes up, this one goes down. So for example, y is equal to x squared minus 2. So if I put this back to where it was, there's my parent function, and I take all of my y values, so I'm moving on the y-axis, I'm moving up or down. If I take all of my y values and I negate them, or not negate them, but subtract 2, then the whole thing shifts down. All right, let's talk about adding or subtracting in with your x values. So we are impacting our domain values, our x values. So that means we will be shifting left or right. So when you are adding or subtracting from your y values, it's going up or down. If you're adding or subtracting to your x values, it's going left or right. So this one's kind of counterintuitive here, and this does not want to seem to let my pen go. There we go. So if I give you y is equal to, and I have to put this in parentheses here, and I say x plus 5. Now if you think about your roots, what would make that 0? If you think about your roots, what would make this 0? Hopefully you're thinking negative 5. Therefore, this actually goes left 5. It's kind of counterintuitive. I'm going to put this back here at the origin. So this would mean I would shift, believe it or not, the whole thing is going to go over left 5. That moves it left 5. And again, let's try it by this time, instead of saying x plus 5, maybe let's go x minus 3, binomial squared. You have to think, okay, what makes x minus 3 0? Hopefully you're thinking positive 3. Positive 3 means go positive 3 on the x-axis. So that means go right 3. So if I put this back to the original, this is actually going to shift it to the right 3. All right, so if we're adding or subtracting to our y values, this thing goes up or down. If you are adding or subtracting with our x values, it's going to go left or right. Now remember, the left or right is actually counterintuitive. Think of your roots. Think of what makes it 0. Reflection. Okay, so in this first one right here, what we're doing is we're changing all the y values. So if you look at our parent function right now, all the y values are actually positive. They're all positive y values. But if I negate all of them, all my y values become negative. So if I make this so that all my y values become negative, what I'm actually doing is flipping this upside down. So that's what it looks like if you negate all your y values. So that means this reflection, this flips over the x-axis. Now, if I negate the x values, this is an interesting one. Let me put my function back. And essentially what this is going to do is it's going to negate my x values. So right now, all of these x values over on this side, the positive x values. So here's the function where my x values are positive. If I negate my x values, it's going to take those x values and actually, let me grab a hold of my function here, flip them, but it's going to flip them over the y-axis. So look at that, it looks like nothing happened. The reason it looks like nothing happened is this image is symmetrical. So this actually flips, but it flips over the y-axis, and it looks like nothing happened because it's symmetrical. Okay, our last one is a dilation. This is where we either stretch or compress. Now if we're impacting our y values, so in other words this is the same as like taking all of our output values and multiplying them by something. So if I'm multiplying my output values, what I'm actually doing is I'm working on the y-axis. If I'm working on the y-axis, this is going to be our vertical stretch or compression. If I'm impacting my x-axis, this is where you are dealing with horizontal stretch or compression. Now, the biggest thing that I would like you to just be able to recognize is when it gets wider versus when it gets narrower. That's it. If you don't even deal with the vertical stretch or compression versus the horizontal stretch or compression, as long as you can understand when this gets wider and when this gets narrower. Okay. If we have a decimal between, say, 0 and 1, this is actually going to look like it has been compressed. Okay, so this is going to look wider. So for example, y is equal to 1/2 x squared. What this is going to do is take all of our output values and take half of them. So in other words, your output value here is 1, take half. Right here, input 2, you get out 4. Take half. Input 3, you get out 9, take half. That's going to be 4.5. I'm going to do the same thing on the other side. Take half of -1, take half of 4, take half of 9, and you'll notice when you take half, look at that, this thing gets wider. Okay? Now, if you were to do y is equal to 2x squared and double all of those, this should make it look vertically stretched. So in other words, if I go to 1, my output for 1 is 1, double that. If I go to 2, my output is 4, double that. Here my output is 9, double that, that's 18, it's off my graph. So you'll notice this looks definitely narrower, and I'm not very good with drawing on this, so I apologize. When you multiply your x values, it gives you the exact same look. However, we will be multiplying the x before we square it. So for example, if I did y is equal to 1/2 x and then square it, that's going to make a bit of a difference. For example, if I put in 1, that is going to be 1/2 times 1. Now squared, that actually gives you a 1/4. If I put in 2, 1/2 times 2, that gives us 1. Squared is 1. Put in 3. So you're going to do 1/2 of 3, which is 1.5. Square it. That is going to be 2.25, and so on. So it's going to have the same, it's going to look similar, but your output values are going to be actually a little bit lower, so it may look a little bit more wide. Okay, let's keep going. The cool thing about vertex form, if I give you an equation in vertex form, say y is equal to x plus 3 whole thing squared minus 5, then this tells me that this is going to go left 3, and this tells me it's going to go down 5. So if you want to know what this is going to look like, it's going to go left 3, down 5, right there. If I were to give you y is equal to x plus 7 plus 1, this means I'm actually going to go left 7, up 1. So I'll take this, put it back. It's going to take all of my points and go left 7, up 1. If I give you y is equal to, we're going to negate and we're going to say x minus 3 whole thing squared plus 4, then this is going to go right 3 up 4, and it's going to flip. And it's going to flip over the x-axis. So let me go right 3. There's right 3. Let me go up 4. And now I need to flip it. Oop. So I'm going to have to move this back. So would we say right 3, up 4? This is what it's going to look like. So that's the cool thing about vertex form. Let's take a couple look at some Regents questions. I don't remember which test this was on, but if we're looking at this, it says how does the graph of f of x compare to the graph of g of x equals x squared? Now the nice thing is you have a graphing calculator. If you forgot all this, you could put it in your graphing calculator. That's fine. But let's go piece by piece. The minus 2, before we even look at our choices, I would do this. I would say, okay, the minus 2 is going to make this go which way? Well, hopefully you're saying what makes this 0 is positive 2. So that means this is going right 2. The plus 1 means up 1. And the positive 3 is going to make this look narrower. Okay? So now let's read through the choices. The graph of f of x is wider. Nope, definitely not wider. The graph of f of x is narrower. Good. And its vertex is moved to the right. Now that may look confusing because it says the vertex is moved. All the points are going to move. So that includes the vertex, and all the other points would move to the right 2 and up 1. That is true. That is correct. If I look at choice 3, it says narrower, which is good. And its vertex is moved left 2. I would guess that a lot of kids probably chose that because you see the minus 2 and you think left 2. 4 is incorrect. I see the word wider, so I'm saying definitely not that. Let's take a look at this one. The vertex of the parabola is represented by f of x is equal to x squared minus 4x plus 3 and has the coordinates of 2, negative 1. Find the coordinates of the vertex of the parabola defined by g of x equals f of x, but you're minusing 2 from your x values. So let's just look at this. You know when we're minusing 2 from your x values, what's that going to do? Hopefully you're looking at that and saying, okay, well that's going to move it to the right 2. So if I graph 2 comma negative 1, right, I'm going to graph that right here. According to this, it says go right 2. There's me going right 2. The new coordinates are 4 comma negative 1. And if you think about it, all we did was we took our x value, okay, and I went to the right 2, which means I actually added 2. Okay, let's try another one. All right, in this problem, we've got the function, which is f of x, and then we've got g of x, which means take f of x and add k. So it takes f of x and adds k. Well, let's see. F of x is our original. Oh boy, I'm not good at drawing that. And then g of x is actually moved down. So what we did here is we went down 2. Down 2. So if we want to go down 2, what would k have to be? Hopefully you're thinking minus 2. That's your answer. Now a typical question that I would see with this, let's move this up. Okay, so one of the questions that you could see, the question could be worded as, what is the new equation of g of x? And basically that's actually a very easy question, because if g of x is equal to f of x minus 2, right, because we said it was going to be minusing 2, then g of x is actually equal to, let's see what f of x is. If you go up on the top, I'm going to take that equation and I'm going to put it right down in here. So I'm going to go x squared minus 6x plus 9 minus 2. So that means your g of x is actually x squared minus 6x plus 7. And that's your new equation. Neat. Let's try one last one. You have a few of these on your practice. So which of the following represents the new function? And this symbol right here is actually called a prime symbol. And that means that's your new function. After the original function has been translated left 7. Okay, so left 7. So if I want to go left 7, would this be x plus 7 or would this be x minus 7? I want to go left 7. Okay, so you are going to say hopefully, what, plus 7? So now we know that this is going to be f of x plus 7. Then what I'm going to do is I'm going to take f of x, and wherever I see an x, I'm going to put in x plus 7, right? Because in order to go left 7, you have to add x, you have to add 7 to x. So in order to go left 7, you have to add 7 to your x. So all I'm going to do is everywhere I see the x, I'm going to add the 7. Because that's how I go left 7. And I'm guessing you probably know what to do from here. I think we're going to multiply it out. So f of x plus 7 is equal to negative 3. All right, to square that, remember you have to FOIL it. So I've done enough of these to know that that's got to be x squared plus 14x plus 49 plus 6x plus 42 plus 3. So f of x plus 7 is equal to negative 3x squared minus 42x minus 147 plus 6x plus 42 plus 42 plus 3. So f of x plus 7 is equal to negative 3x squared. Combine my like terms here. Minus 36x. And it looks like minus 102. And there better be one of those choices up there that matches, and it is. It's D. What I'd like you to do right now is I'd actually like you to get on Castle Learning Online. They had a lot of great questions on this. Some of them are old Regents exam questions. There's about 15 of them, but a lot of them are very, very fast because they're just asking what would happen. Would it go left or would it go right? Would it go up and down? So some of these are pretty quick. I did give you about 3 of these last type questions, and those can be a little tricky. So good luck, and contact me if you have any questions.